We're going to work through examples 4 through 6 from the notes P.1, and we're going to continue talking a bit about absolute value. So remember, absolute value is the distance between a point and the origin, and we can also use the absolute value to find the distance between 2 points on a number line. So the distance between 2 points, A and B, on the real number line is simply the absolute value of the difference. So we can do, if we have points, numbers A and B, we can do the absolute value of A minus B, or the absolute value of B minus A. Those will be the same values because when we take the absolute value, the output will be 0 or positive. It will never be negative. So let's try example 4. Find the distance between negative 3.5 and 12. So we can do this in two different ways. I can say that's the absolute value of negative 3.5 minus 12. And then I would do the part inside the absolute value. So that would be negative 3.5 minus 12 is negative 15.5. And the absolute value would say to make that positive 15.5, because that's the difference between 0 and negative 15.5 on a real number line. We could also do it, and there's no reason to do it both ways, but I will for today. We can subtract negative 3.5 from 12. So we have 12 minus negative 3.5. And we take the absolute value of that to find the distance. That becomes the absolute value of 12 plus 3.5, which is the absolute value of 15.5. And the absolute value of a positive number is simply that number, so we get 15.5. So 15.5 is the distance between negative 3.5 and 12. Next, example B. Use absolute value notation to describe the distance. So whenever we see distance, we know we're going to use absolute value between x and negative 10 is at least 6. So because it has distance, I'm going to put absolute value. We're finding the distance between x and negative 10. Those are like our 2 points, A and B, up above in our examples. So we can subtract it either way. So I'm going to say the distance between x and negative 10, that distance is x minus negative 10, is at least 6. At least 6 would be represented as an inequality as greater than or equal to 6, and then we should simplify inside the absolute value, so we'd have the absolute value of x plus 10 is greater than or equal to 6. Next thing we're going to talk about is algebraic expressions. So in algebra, letters are used to represent variables most often. And an algebraic expression is a collection of letters, which are variables, and numbers, which we'll call constants. And these are combined using the operations of addition, subtraction, multiplication and division, and exponentiation. So I have an example of an algebraic expression here. So we've got 7x cubed plus 5x squared plus 9. And we're going to identify some terminology about this algebraic expression, and you should be familiar with these terms. So 7x cubed minus 5x squared, those two are going to be our variable terms because they have the variable x in them. And the 9 over here, this 9 is a constant term. So in terms of this terminology, terms are those parts separated by addition. So the expression that we have up above, 7x cubed minus 5x squared plus 9, has 3 terms, right? Those terms are 7x cubed, 5x squared, and 9. The number in front of a variable term is called the coefficient. All right, to evaluate an algebraic expression, we substitute the numerical values for each of the variables in the expression, and usually we'll just say plug it in. So for example, if you want to evaluate 3x squared minus x plus 4 for x equals negative 1, we simply substitute negative 1 in for x everywhere that x appears in the expression. So this would become 3 times the quantity -1 squared minus -1 plus 4. Simplifying this, we get 3, -1 squared is 1, so 3 times 1 minus -1 is +1 plus 4, and that will give us 3 plus 1 plus 4, which is 8. Basic rules of algebra is the next little topic, and I had asked you to read the basic rules of algebra in your textbook prior to today's class. I'm not going to go over all those rules. You've learned them in the past. I'm going to just emphasize a few that we will use often. So example 6a, if we look at this, we have the quantity 3 plus x plus 4 equals 4 plus the quantity 3 plus x. So see if you can figure out which property this is. If you need to, stop the video and see if you can answer it and then come back with me. So when I'm looking at this, I'm seeing that the order is changed, right? Because we're switching where 3 plus x is. So we have 3 plus x plus 4, and then that's the first quantity. On the other side of the equal sign, the 3 plus x is the second quantity. So when we're talking about order, this is the commutative property of addition. And that tells us when we're adding that order doesn't matter. The next one I want to highlight is I've got the quantity 3 plus x plus 4 equals 3 plus the quantity x plus 4. So what's happening in this one, I'm not reordering the terms. You see I have 3 plus x plus 4. In each case, the 3 and x and 4 are in the same positions. But what's changed here is the grouping. And so this property is the associative property. And that tells us that we can regroup terms. And I think of this as the associative property. If you associate with someone, that's someone that you like to hang out with. That's someone in your group. So the associative property allows us to regroup terms. In example 6c, we have 3 times the quantity x minus y is equal to 3x minus 3y. And this is our old friend, the distributive property, where we have to multiply each of the terms within the parentheses by the 3, which is outside the parentheses. And the last one, 6d, we have the property of a times b equals 0, then a equals 0 or b equals 0. We will use this property very often when solving equations. And this property is called the zero product property. And what it says is if you have a number of factors that multiply to 0, if the product is 0, then at least one of those factors is 0. And we could have this for multiple factors, right? If I have a times b times c equals 0, I could extend this. Then a equals 0, b equals 0, or c equals 0. It tells us at least one of the factors is 0.